Let's start with a slide on data modeling, right? So what exactly is a data modeling? So it is a crucial process that helps organizations analyze and organize their data to make informed decisions, right? So you can understand how important is data modeling, right? So what I'll do is I'll give an example of the supply chain oil and gas, which we have already used as a use case in our previous series on Azure end-to-end Azure data engineering project, right? Since that particular use case is really liked by all, so I'll just want to go much more granular into that particular project, right? So since like most of the project that you'll get probably will involve data modeling at the very initial aspect of your project, right? So what I'll do is I'll just take the same use case for those people who have not watched our video on real end-to-end Azure training on supply chain. Please have a look. Even if let's say you did not get a chance to have a look and you're directly starting with this data modeling concept, you don't need to worry because we are just using that use case as an example here, though the concepts remains the different. Okay, so let's start with this data modeling where I'll be taking some example on this same oil and gas company. Let's say there is a company which deals with some oil and gas domain. Okay, so now let's say this company in the oil and gas is having multiple divisions. Okay, so let's say they have an engineering team, they have procurement team, then they have shipping team, then they have, let's say, logistics team. Okay, so this particular business is having four different teams or four different verticals, right? Now let's say this company, some X company which deals with this oil and gas, comes up with some business requirement that they wanted to reduce their cost, okay, in supply chain. Okay, now this company want to reduce their cost in a supply chain, and they have this engineering division, procurement division, shipping division, logistics division, right? So each of these division will be having their own set of data, right? Engineering team will be capturing the data that is related to the engineering team. Procurement team will be capturing the data that will be related to procurement team, like what all materials that they need to procure. Shipping team will be having the data of all those items that are shipped. Logistics team similarly will have all those data which related to logistics, right? So independently they have their own data that will be stored based on their own departments. Correct. Now, let's say in order to solve this business problem, which is how to reduce this cost. So this reduction of cost will be dependent on each of these departments. So the more optimized process that you do in each of this department will lead to reduction of costs. Correct. So in order to perform this business requirement, you must need to you must have to make these data among different teams to interact with each other, right? So let me just open a whiteboard so that it will be uh, more helpful for viewing. Okay, so as I'm saying, let's say we have one data that is with respect to engineering team. Okay, then we have one data that is related to procurement team. Okay, procurement team. Then we have some data with regards to shipping team. Then similarly we have a data for logistics team, right? So now these all of these data belongs to a different verticals or different division. Right now our intention is to reduce the cost. So in order to reduce this cost, there must be some kind of a dependency that needs to be built, or a relation that needs to be built, so that we can have a overall view of the entire business process in order to reduce their cost, right? Let's say if the engineering team is responsible for sending the materials list to the procurement team. Okay, let's say there is an engineering team. What it will do is, for all those material that is required for a certain process, it will send to procurement team, where procurement team will be taking those material requisition list from the engineering team, and then they will be passing it to some other team, probably. Let's say if they have a data for suppliers, so we have supplier data. So this procurement team will be having supplier data, then the supplier will be doing some kind of a shipping, and then there will be some kind of a logistics. So all of these are basically dependent, and all is like a kind of a flow, and all of these are related to cost, where the engineering team could be related to cost, procurement team could be related to cost, supplier could be related to cost, logistics could be related, same way shipping could be related to the cost, right? So basically, what exactly is a data modeling is like collect info regarding business requirement. So where we are collecting info regarding business requirement, as in we have to reduce the cost, correct? And we have to translate this business rule to kind of a data structure, to data structure. Like basically some kind of a structure we need to translate it in order to have some kind of a business rule establishment, right? So in order to uh, solve any business problem, you must first collect information regarding the business requirement, and then you must translate those business requirement into some data structure, right? Or translate those business rule into some kind of a data structure, right? So that's what is basically data modeling, right? Like let's say where you are, let's say whatever the data that you have, let's say you are getting data 1 from engineering team, you are getting data 2 from procurement team. Let's say just data 1 could consist of multiple tables, T1, T2. I'm just taking it as a whole. Okay, let's say similarly we have different data coming from each of the different teams, right? So we, in order, the process of analyzing all these data, right? So process of analyzing all these data and defining all the different data types of this data. What is the data type? Like it could be an integer, it could be string, varchar, and varchar, it could be date time, right? So defining the data structure, like data type, and analyzing the data for your business requirement and establishing a relationship between them is basically a data modeling. Okay, so data models are built around the business rules. Based on the business rules, data models are built, right? So let us just come to our slide. So in this slide, we will be discussing about what are the types of data modeling. Okay, so there are multiple types of data modeling, and each type is basically suitable for some kind of a specific requirements. Okay, so let us just go one by one and try to understand these what are the different types of data modeling. So I'll just go to the whiteboard. Okay, so let's say the very first type which we can have is a hierarchical data model. Okay, so let me just show it to you how exactly it will look like. Okay, so let's say we have some structure like parent and child. Okay, so let's say you have some node like this here. Let's say if it is divided into three other childs, let's say one, let's say two, let's say this is the third one. Okay, now let's say this is further divided into another two. 1, 2, right? So this is basically nothing but hierarchical data model. Okay, so what exactly this is suitable for? So this is suitable for all those structures where we want to represent a parent and child relationships. Like this is a parent and this is having three childs. Now for this child node, which is basically acting as a parent for these two child nodes, right? So one parent, basically one child can have one parent, right? But one parent can have multiple childs, correct? So that's what is the hierarchical data model. Okay, and it actually it was used in early database systems. Okay, so now coming to the some other data models, what which is relational data model. Okay, so let's say if I'll come to the relational data model. Okay, so this is basically ideal for managing structured data where relationship between entities are well defined. Okay, so entities, what exactly entities means is like a column. Okay, like let's say we have some structured data. Let's say if I'll talk about a table which is like, let's say this, let's say we have some sales table, sales. Okay, it could have some kind of an id columns, let's say some measures, fact, something. Okay, now let's say this sales table is connected with another table which is a vendor table. Right, let's say it is connected with vendor table. Similarly, we can have another table, let's say product. So this table could be connected to sales like this. We can have customers who will be buying product and doing the sales, correct? So like customers will also be connected. So this is what is basically relational data model, where relationships between the entities, these are the entities, sales, customer, product, vendors are the entities. So the relationship between these entities are well defined, right? So let's come to the other one, which is entity relationship data model. Okay, so let me just clear it. Second, yes. Okay, so if I come to the ER model, which is entity relationship model. Okay, so the ER model will help you to visualize or design database structure by showing entities, their attributes, and what is the relationship between their entities. Okay, like let's say you have customer. Okay, you have products, right? Now customer, how is it related to product? Let's say it buys products. So customer buys product. So that's how customer is related to the product, right? So entity relationship data model will basically used during the conceptual phase of database development to model the real world scenarios. So we will be discussing the what are the different phases of database development, right? So but ER modeling we can use particularly in the conceptual phase. Okay, so now let's come to the other one, which is object oriented data model. So object oriented data model. Okay, so object oriented data model is basically suitable for representing any complex or real world entities and what exactly is their interactions, and it is also used in the software development, especially in the object oriented programming language like Java, C++, right, where you have basically class like class and the objects, right? So it is more like if I'll give you an example, probably let's say we have three classes. Let's say we have customer, then we can have product, so this is related. So basically different classes which we can see, we can just show them in object oriented data modeling, right? uh, for all those like let's say in the software development or in object oriented programming language. Okay, so that's what is object oriented data model. Now coming to the last one, which is dimensional data model. Okay, so if I'll just show you what exactly is the dimensional data model, let me just select this. Okay, so if we basically dimensional data model was given by Adolph Kimball. Okay, where it was basically applied in data warehousing for efficient analysis and reporting. So it is applied for data warehouse for analysis and reporting. What are we talking about? Dimensional data model. Okay, so basically what it does, it simplifies complex business process by understanding or organizing data into easily understandable dimensions. Okay, and it will it will change the data to dimensions, right? So what it how it will help, it will support the decision making in areas like you could say sales, finance, marketing. Like let's say you have a table where you have divided this table into some fact and some multiple dimensions. Okay, so this is basically one of the visual representation of a dimensional data model, which is also called as the star schema. So we will come to this particularly in our coming slides. Okay, so this is what is dimensional data model. So now let us just go back to our slide where we have already covered all of these five types of data modeling: hierarchical, where we have tree-like structure; we have a relational data model; then we have ER model, object-oriented model, and the dimensional data models. Okay, now coming to the next slide, which is with regards to the process of data modeling. Okay, so what exactly is the data modeling process? Okay, we go to the whiteboard. So you must be thinking, okay, I have like you understood, you data modeling is something which will be helpful for let's say collecting information regarding business requirements and translating into business rule to data structure, right? But how exactly you should start the data modeling? What exactly is the process? Okay, so let's say if I'll give you an example where we are having different data sources, right? Where we are having engineering data, where we are having procurement data, where we are having shipping data, where we are having logistics data, right? So let's say we are having engineering, procurement, shipping, logistics, correct? So first of all, you should have all of these data in, so that you could build some kind of let's say logic or some kind of a process in order to make this data interact with each other, right? Like let's say I'll just give you an analogy. Like let's say you want to build a house. Okay, so in order to build a house, what exactly you will do? First of all, you will uh, have a word with an architect, correct? So first of all, you'll go to the architect, and then what you'll do first, you will give your requirements to the architect. Requirements like, okay, I want a house which should have enough open space. Let's say you should have a good natural light, coming in. Then we should have some cozy atmosphere. So this is something, let's say, your requirement that you will be giving to the architect, right? So this requirement, and which is open space, natural light, cozy atmosphere, is nothing but a conceptual model. Okay, like basically you have your requirement, you have the concept, but you have not much went into the details of it. Okay, so now let's say once you give all of this requirement to the architect then what it will do is it will design, let's say, some floor plans. Correct, it will design some floor plans, it will allocate some space, let's say for bedrooms. Correct, then also it will determine how each room will connect. Correct, so this there must be a relationship between each rooms, right, in order to connect, in order to travel from one to another. So all of these informations, all of these plans will be coming into nothing but a logical layer, logical plan. So this is, now you have moved from some conceptual and now you have put some logic into it, right? Now let's say you have passed this blueprint which is having some floor plan and then bedroom space. Now you understand where is your master bedroom, where is your let's say dining room. So once all of these are into place, then you will go for more specifications, like what will be the materials that will be used for wooden requirement, let's say. Then what kind of bricks that you would need, what kind of wood that you need, basically detailed specifications, right? So this is nothing but a physical layer of the data modeling design. I hope you would have understood this. So let us just come to the slide where, if you see, first of all, you will have to get a requirement. Probably what requirement is it? You need to identify what are the data entities, what is the relationship between these entities and all, right? Then you need to have a conceptual modeling where you can create an abstract representation of data entities and their relations. So like kind of an if I talk about it in the terms of tables, like let's say where we have okay, let me just do one thing. Probably I'll give you one example. Let's say we have some sales table, let's say like this, sales. Okay, now this sales table could be from multiple stores. Correct, now we could have another table as, let's say, time. Correct, then with this sales could happen also from product, right? So if you could see sales, stores, product, time, if I'll talk about in some kind of a tabular format, let's say this is these are the entities where we are just defining the entities. So all of these are entities, and what is the relationship between them? Like here, if you could see, sales is connected to product and time, it is also connected to store, right? So basically we are showing the data entities and their relationships here. Correct, so that's what is conceptual model. Now coming to the logical modeling, so let's come here. Okay, so for the same example, let's say, which we were seeing, Okay, let's say we were having a sales table. So let's say if this is a sales, so what all column this sales table could have? Okay, so let's say if this is a fact table, so let's say if it is having product ID, let's say store ID, let's say date, and something. Correct. Similarly, we can have a table which is store table, right? Which we saw store table, which will have store ID and remaining other columns like could be product description and so on. Similarly, this sales table could have another table which is product, where we can have all the details which is with respect to the product like product ID, product description, and other stuff. Similarly, we can have other table which is time, right? Where we can have month, year, week. Let's say this now this primary of this product ID is basically coming from this table, which is the primary key for this table, but for this table it is a foreign key. Correct. I hope you guys would be knowing what is primary key and what is foreign key. If not, I'll just give a brief uh, intro. So let's say for this table, this product table which we have, this product ID is the column which uniquely identifies this table. Like we cannot have same product ID for two different products, right? And here in the sales, we are referring this product ID, which is the primary key of this product table, but since we are referring it here, we are referring it as foreign key for this table, right? Similarly, store ID is a foreign key for this table, and if I'll talk about some date key and all, that will also be a foreign key. Okay, so this is what we have as a logical data modeling. Right now we are good with the conceptual data modeling, where we have just defined the entities, which was sales, store, time, product. We gave the relation between them, right? And then in this case where we are into logical, is apart from this we have also put few more uh, information which is with regards to their attributes, right, and the relations. Now coming to the last part, which is nothing but the physical data modeling, right, which is the detail, basically more detail or more granular level of abstraction, correct? So where it is like where we give the analogy for the architect, if you're building a house, where which material which you are using, right? Similarly, like for these tables you can have an additional let's say fields where you could mention their data types as well. Let's say this is an integer, integer, like this. Similarly, you can mention it here like integer and varchar. So similarly for these ones as well. So this is what is called as physical data modeling. Okay, so let me go back to the slide. So we are good with the requirement gathering. We understood the requirement. We started with some conceptual modeling, then we went to the logical model modeling, and then we went to the physical modeling. Okay, so that's what is the process of a data modeling. Now let's come to the next slide, which is the importance of data modeling in database design. So first of all, if you could see, the very first point is organizing the data. So as we saw, like based on the different types of data modeling, either it could be hierarchical, it could be object oriented, dimensional, whatever it is, ER, all of there we could see we are building some kind of a flow where we are, which is basically helping us to define the structure of the data. right? So that's where is it's one of the most important part is where we are organizing the data by defining the structure of database, so that making it easier to organize and manage, correct? The second part, which is reducing the redundancy basically. Okay, so by eliminating the data redundancy, data modeling enhances efficiency and reduces storage requirements, right? Obviously if the duplicates will be removed, the storage that is being occupied by those duplicate records will be free, right? And that's how it will reduce the storage requirement. How exactly we are reducing the redundancy? We are reducing the redundancy by, let's say, denormalizing, right? Let's say for one of the dimension modeling that we do, where we have a star schema, we will be having one fact, and then we will be having multiple dimensions that will be directly connected to that fact basically, right? So there what we are doing is we are having you could say one star schema, and similarly if there will be a fact and there will be a dimension and there will be one more dimension that will be connected to it, so that means that is more normalized, right? Since we are dividing dimensions onto multiple dimensions there, so we are basically normalizing the tables. Okay, so we will be coming to these topics in coming slides. Okay, and that's that how do we reduce this redundancy. Now coming to this improving data quality, so data modeling also ensures accurate and consistent data by enforcing constants and relationships. So if we are defining relationship between between different tables like student, customer, products, right, we are establishing a relationship by creating foreign key constants, right? So basically this establishes a relationship between different entities, and that ensures that data is more accurate and consistent. Okay, now coming to the next slide, what exactly is fact table and what are dimension tables? Okay, so fact tables are those tables which contains the measurement, metrics or fact of a business process. Okay, similarly a dimension table is basically a table that provides descriptive attributes related to the fact in the fact table. So let's say, uh, I'll just give you an example probably. Second. Okay, so in the same example, if you will see, we have a table which is sales, which is having, let's say, product ID, which is having store ID, which is having some date, and let's say amount, or okay, what amount, for what amount this product is sold, let's say. Okay, so if you see, basically these are having all those data which is mostly numerical, and it can be used for certain kind of an analysis, like which store is having the maximum sales amount, right? Which product is having the maximum sales amount, correct? Or on date this, or on today's date, which is the maximum, which is for which product there is a maximum sales, right? So all of these kind of an analysis is being carried out from this particular table sales, which is having all these data as measures, which is nothing but numerical facts, so which is called as a fact table. Okay, and if I'll talk about, let's say if I'll take this product ID which is connecting to this product table, so here in this product table, if you'll see, we have product ID, and that's how it is connected to this sales. But let's say if you want to, let's say if you want to figure it out, which product is having the maximum sales today, you get to know, okay, product ID, let's say 101 is having maximum sales. Now, in order to get the detail of this product, we have kept all these details into another table, which is a product table, which is nothing but a dimension table. Okay, so this dimension table, which is product dimension table, is having all the data which is related to the product, all the description of a product. So which we have product ID, we have product description, we will be having product name, and all the informations which is descriptive basically and is related to product. So that's what is called as dimensions. Okay, so anyways, in the coming slides, we will be doing use case. So you will be understanding there clearly what exactly is dimension, how do we create dimensions, what is the fact. Okay, so for now let us just proceed. So we have understood like fact tables contains the measurement, metrics or facts of a business process, right? Dimension table provide descriptive attributes related to the fact in the fact table. Okay, now there are two types of schemas which are very common and is very important for interviews. There is star schema and snowflake schema, right? And it is used to organize fact and dimension tables. Okay, so coming to the next slide, let's come to the dimension table design. How do we design the dimension table? Okay, so very first point, we have primary key and we have unique foreign keys. Primary keys uniquely identify recorded a dimension table, while foreign keys establish relationship with fact tables, right? So if you'll see here, primary key is, let's say this is the primary key. It uniquely identifies this product tables. That means there cannot be two different product ID in this product table, because product there cannot be two different ID for the same product. Okay, for one product, let's say if it is any product, let's say if it is uh, Britannia, and let's say some kind of a biscuit, then we could give it some ID1. Right now the same biscuit, whenever we are trying to refer it, it will be having same product ID for all the times. Okay, so that's what is called as a primary key. And since this primary key is being referred here in order to join this particular table, this is called as a foreign key here. Okay, so foreign key establishes relationship within the fact tables. Now coming to the second part, we would be needing attributes, we would be needing hierarchies. So attributes provide additional information about dimensions. So attributes is nothing but let's say if I'm talking about a table, let's say customer table, if customer is an entity and attributes are customer ID, customer name, so all those additional information with regards to the customer, while hierarchies define the relationship between the attributes. So how exactly these attributes are related to each other, like let's say we have customer ID. From that customer ID we can have customer name, customer description, customer phone number, customer address, right? So that we can keep it as a hierarchy. Now coming to slowly changing dimensions, so that is a very vast topic, and it is also very important for interview perspective. So slowly changing dimensions basically handle changes to the dimension data over time. So it preserves historical as well as current values depending on the SCD type that you use. So there are multiple slowly changing dimension types that is available, like SCD type 1, SCD type 2, SCD type 3, and so on. So we will be basically using our use case there. We will be designing our dimension as SCD type 2, where we will be capturing the historical data as well as we will be capturing the current data. Okay, if I'll give you an example, let's say if I'm talking about the customer table. Okay, let's say I have a table which is a customer table. If I'll open it, let's say we have customer table. It could have customer ID, it could have customer name, customer phone number, let's say customer address. So what could you think of? Let's say customer name is something, let's say the name of our customer who is buying our products which won't get changed, correct? So this won't get changed. Customer ID is something that we are assigning in order to uniquely identify the customer, so this will also not change. Customer phone number is something that can change. Customer address is something that could get changed, right? Now there are multiple ways to handle this data. Let's say tomorrow if your customer, let's say today if they are residing in India, okay, you must have that India stored into your database. Now let's say if the customer moved to US, let's say you might be providing some different kind of an offers to that particular customer. Now if you want to let's say if you do not want to have this update into your table, what you could do, you could just ignore this data by, let's say, just whatever, like let's say you have a column customer address where you will be having the India, you could just overwrite it. Instead of India, you could write US. right? So that means you are not capturing any historical data. Now, so that is something which is it comes in type 1. Now coming to the type 2, where what you want to do is you want to have this historical data that is there. Also, you want to maintain the current data. So let's say you can have additional columns like let's say status column, which could say like current. We could have start date, and you can have end date column, so that you could see like, okay, this status, this one, this is one, this is active, this is zero, this is not active. And you could give that, okay, when was the starting date for this address and when did this address got ended, and after that date will must be the start date for this, and when this get ended, right? And that's how basically you will be capturing the historical data for all of these customers, right? So, so it is nothing but how exactly do you want to store your historical data of any of this dimension is what we do in SCD type 2. Okay. So now let's come to the slide. How do we design the fact table? So fact table, if we saw in our example, which was the sales table, right? So first of all, we should have measure, where should be some quantifiable data elements, right? Which and that provide insights or support calculation. Then there should be some kind of a granularity where at which the data is stored, analyzed within the fact table, right? Let's say if I'm talking about this fact table, which is nothing but the sales, this amount could be based on different granular. Let's say it could be based on different product, it could be based on different stores, right? So that's what is the granularity. And then we have to choose what dimension. So once the grain of the fact table is stated clearly, it is the time to determine dimension for each fact, like what all dimensions do we need. Okay, that's what is the process of fact designing. So coming to the star schema and snowflake schema. Okay, now since we have understood what is dimension and what is fact, you must know this particular schema here. So let us just start with the star schema. Here, if you could see, this is a fact table, right? This fact table is connected directly with multiple dimensions, and this is looking something like a star, and that's where we have called this as a star schema, where you will be having central fact table surrounded by dimension tables. Okay, similarly, for this example we have a snowflake schema, where if you could see, we have a fact table, then we have one dimension here, and this dimension is basically split it into other dimensions, right? Similarly, we have one dimension here and all of these places, right? So this is basically the difference between star schema and snowflake schema. And now coming to why do, when, like, let's say if I'll come to the difference between these, like let's say if I'm talking about the star schema, so you should use the star schema where you are more particular about query performance. Okay, so why I'm saying like that? So let's say here in this case, fact table, we have one dimension. This dimension is basically split across the other two dimensions. Let's say the same dimension here. Let's say if I'm talking about customer dimension, if it is okay. Now I'm splitting this customer dimension to other smaller dimensions. Now let's say I have this customer dimension here as well. Let's say this dimension is address. Okay, so now if I want to do some query where I want to figure it out for those customers who are residing in location India, what I have to do is, since this customer dimension is not having that location, so I have to join these two tables from the fact, and then I'll have to figure it out what exactly is the query result. In this case, I don't have to join to any other table apart from this fact. So we have less number of joins here, and that is the reason we will be having a slight better performance of the query execution in terms of star schema. Okay, now it is basically where exactly could we use star schema. So we could use star schema for our data warehouse solutions, where we are basically more interested on the BI or reporting side. Okay, now Basically, it is also used in those conditions where we have very simple relationship between dimension and fact. Okay, now coming to the snowflake, like if you could see, this is a very simple relation, right? All of the dimensions are directly connected to the fact. Now coming to the snowflake, basically you should use snowflake when you are much concerned about, let's say, data integrity. Why? Because here we have normalization. Since we can see one dimension is spread across multiple dimensions, we do not have much data redundancy, hence we have much more data integrity, right? And then we have let's say a complex relation between dims and facts, dimension and facts basically, right? So that's what is the difference between this star schema and snowflake schema. Okay, wherever there is a need to reduce basically data redundancy, and if you have the storage efficiency as critical, so you must go with snowflake schema, right? And let's say if you want to go for let's say better performance in the queries, like let's say mostly in the aggregation queries, you could go for the star schema, right? So and that's how we decide which schema to use. Okay, now coming to the use case, so we have enough discussed regarding what is dimension, what is fact, what is data modeling, right? But until unless we won't do practical, it won't make much sense. Okay, so that's the reason we have added a use case to this. Okay, so let me just share you an Excel which shows a data, the kind of a sample data for you guys. Okay, so let's say we have this data. Okay, so if you could see, this is a sample banking data set. Okay, where we have all of these columns. I'll just go through these columns. Let's say we have some kind of a transactions that has happened for some specific customer. Let's say transaction ID 1, customer ID is 1001, right? What is the customer name? John Smith, right? Now, what is the customer address or date of birth, customer email ID? Similarly, the customer might be having some kind of an account in that bank. So, what is the account ID? What is the account type? Whether it is a savings account, is a checking account? What is the balance? When was the account opened? What and we are also having a transaction date. Then, what is the location ID, location name, city, state? What is the amount in that particular bank or account? What is the transaction type that was done? What is the branch name? Which day, which month, which year, right? So if you could see, this is one of the data that you have. Okay, now if I'll talk about this one data which we are getting in some kind of an uh, oracle, let's say. Okay, if I'm talking, let's say I have these data into some kind of an ERP. Let's say if I'm talking about a supply chain where we can have a procurement data instead of this customer, let's say if we are having a suppliers, right? So all of these data, let's say if it is a sales data or if it is a transaction data in banking use case, let's say if it is stored in some kind of a database which could be on-premise SQL server, or let's say if it is stored in some kind of an Oracle ERP where you have this data. Okay, now uh, let's say how exactly you should proceed. Now let's say if I want to do some certain kind of an analysis on this particular data, let's say I want to know which city is having the most like which city, from which city those customers belong to, who is having the maximum balance in their account. Or let's say if I want to figure it out, which are those customers who are having maximum balance into their account, right? So all of these kind of analysis that we need to do, let's say, that could come as a business requirement, let's say, correct, that could come as a business rules, or a requirement which we need to fulfill. So in order to do that, we must have to analyze this data. Okay, so let's say if I'll what we will do here is, we will let's say we have this data as a source. Now we are starting this as a data modeling. Okay, so we will try to first split this data into multiple dimensions. Okay, but before doing that, why are we doing that? Okay, let's say I have this data and I don't like duplicates or any redundancy. Okay, I want to have this data for a data warehouse solution where I want to have it for some kind of a BI or reporting basically, right? So as we have just uh, in the previous slide we have understood, for any BI or reporting or for data warehouse solution we should go for star schema, right? So in order to go for a star schema we need to have one fact, and we need to have multiple dimensions that will be connected directly to that fact, right? So how should we think of dividing this basically table into a different kind of facts here? Okay, so that's what we have to think of, that's what a data engineer has to think of. Okay, so let's say if you could see here these four columns: customer ID, customer name, customer address, date of birth, email address. If you see this, this is looking more of a information that belongs to customer, right? If all of these information, if we will see, it could belong to customer, right? Now similarly, account ID, saving account type, basically balance date, open date, all of these information which we could say is acting like a account informations, correct? Similarly, transaction date is something which could be with respect to the fact table, which is some kind of a measure that we could use, correct? Then we have some kind of a location name, city, state. So if you'll see this location ID, city, state, all of these data is with respect to the location, correct? Now this is amount is something which we need to analyze. This is a transaction date, this amount is done, what is the transaction, probably what is the transaction type, right? And then what is the branch name, and then what is the day, month, year. Let's say this day, month and year, all of these could be put into some kind of a dimension, which is, let's say, time dimension, right? So if I just put it in some this color, okay. So now we have time, we have customer, we have location, then we have account, right? We have time, we have location, we have account, and then we have customer. Now we have, so this is how basically you could think of dividing a table into multiple dimensions and facts. So if I'm talking about this customer table, okay, all of these data into the customer table, let's say I'll go to the sheet 2. All of this data in the customer table is related to this customer ID. Basically, this customer ID and all these customer name, customer address, date of birth is basically the description of this particular customer ID, right? So this is what is called as a dimension, correct? So now we have, let's say, this one dimension as customer ID, then we have, let's say, account ID here, which we nothing but the account table, correct? Then we have location table where we have location ID, location names, city, state. If you see here, right? So we have different locations, sorry. So if I'll go to the time, let's say, okay, then this remaining columns, like let's say transaction ID, and then transaction date, amount, transaction ID, and then transaction date, say I copy this. Okay, so we have transaction ID, transaction date. Similarly, we have amount. We are keeping this transaction type also into the fact, just for those analysis where if we are if you want to do some kind of analysis on the deposit or withdrawal, like how many are those amount which is deposited. So that's the reason we are just keeping this transaction type also into the fact. So it is not mandatory that you always keep numericals into the fact. So basically it is more of a the data that is basically we can do some kind of an aggregations, or it could be some kind of a meaningful data that could come out of it, and so that what you can keep on fact. So if you see here, we have all these four tables as customer table, we have account ID as an account table, we have some time table, then we have some location table, and all of these tables are nothing but related to this particular fact, right? So if I want to join this, like let's say basically how it will look like, it is connected to this fact like this, right? And then similarly we will be having another line from here, where if we could see, we could join this, right? Similarly we can join from here. So I'll not invest much time on this. So that's how basically it will look like. So you'll be having all of these dimensions that will be connected to this fact table, right? So that's how it is called as star schema. Okay, so now let's just do one thing. Okay, let me open SQL Server Management Studio. I'll just open a new query and I'll create a new database with, let's say, data modeling. Okay, now it is created. I'll just select this, I'll just refresh this so that it appears here. Let's see, here it is. Okay, so now as we can see in this table, where we have customer, we have account, we have time, we have location, right? So we need to create these tables. So I have already created the DDLs for you guys so that we don't invest much time on this. Okay, so let us just create tables first. Let's say I have customer dimension table. So if you could see, which is having customer key, customer ID, customer name, and then start date, end date, and current flag. So basically here we are creating this customer dimension table, which is FCD type 2, slowly changing dimension type 2 table, where we are capturing the start date, we are capturing the end date, and we are capturing whether it is a current flag or not. Okay, so let's say we have created this customer dimension table. Similarly, we will be creating account dimension table, where we will be having account ID, which is primary key of this table, then sorry, account key, which is a primary key of this table. We have account ID. So here we have created an additional column, which is account key, which is acting like a surrogate key for this table, right? So which is a primary key here. Similarly, we have account ID, account type, balance, open date, start date, right? So we'll just start date, end date, and current flag we can see also in this table, because this is also a CD type 2 dimension. Okay, now coming to the time dimension, we have time key, we have transaction date, start date, end date, current flag. So let us just create this table as well, where we have this time key as a primary key here. Okay, similarly we have location dimension, where we have location key, location ID, location name, start date, end date, and current flag. Okay, so let me paste it here. So we are good with this four dimensions now. So let us just insert few values to it. So currently we don't have any values to all of these dimensions. So I'm just inserting some random values like customer key as 1234 and then customer ID as 1001, 1002. Then I'm just putting customer name, what is the starting date, what is the end date of this record. So if you could see the starting date of this record, what does this mean? That this customer was added on this 1st January 2022. And what is the end date? It is as 9999. That means this customer is something which is not ended yet, so there is no change. If there would be any modifications to it, we would have been just updating as like 2022, which month and which date. Current flag as one, that means this record is active record. So let me just insert some few sample values. Okay, similarly we are inserting values for the account dimensions, where we have account key, account ID, what is the account type, what is the balance, and then open date, start date, and then end date is this, and the current flag is this. So I hope you would have understood. So I'll just add this sample value. Similarly, now do it for time dimension, where we have time key, transaction date, start date, end date, current flag. Okay, now coming to the next one, which is the location dimension, where we have location key, location ID, what is the location name, when is the start date of this dimension, what is the end date of this dimension, and what is the current flag. Okay, now if you could see, if I'll just open this table, we have created all of these 4 dimension: account dimension, customer dimension, location dimension, and time dimension. So if I just query any one of them, account dimension, let's say, you could see we have this data: account key, account ID, account type, balance, opened, started, ended, current flag, right? So we have created all these 4 dimensions now, correct? So before also, one more thing here, like let's say this is the data that we have got, right? So let us just first create this table as well. So if I'll go to the DDLs, so this is the table which you could see. I have kept the name as denormalized tables. That means it is not normalized, as it is having redundant values and will be having some duplicates, right? Now, how exactly it will be duplicate if it is denormalized? Let's say if this is a table, one table that you have, okay? Now, let's say customer ID 1 has done some kind of a transactions on this date, correct? Now if the same customer could do the transaction on some other date, right? So we would need to insert another record for this customer into the same table. So that means all of, let's say if I'll add one more record here, let's say I'll just copy this. Okay, now let's say here balance I've reduced it to 4k, some transaction date as, let's say, second. Okay, so now this transaction date has got changed, but all of these values with respect to the customer and with respect to the account, similarly with respect to the location, remains the same. So this means we are having redundancy, duplicates for customer, right? So let's say if I add foreign keys here, let's say I'll just add 4 columns. Okay, 1 2 3 and 4. Okay, so let's say we will be having one customer key, then we will be having account key, then we will be having time key, and then let's say we have location key, right? So second, okay, so if you could see, all of these data that we have is basically all of these are the for foreign keys that we are using in order to connect to all of these different dimensions, right? So now if there is any new transaction that a customer does, it will be added here as a new transaction ID for that particular customer key, right? Let's say whatever the key that we have it here. Now it there won't be any duplicate that will happen with respect to customer name, customer address. It will be just a new transaction that will be added here, and that's how we are reducing the redundancy when we are normalizing the any of the denormalized tables. Okay, so if I go back to the SQL Server, okay, where let's say we have the staging denormalized table. Okay, so if I run this, we have created this denormalized table which is having the entire data. Okay, let me go to the DDL and put some sample values. Okay, yeah, here it is. So if I'll just do select query, let me copy the name. Okay, so this is the data that we were looking into the Excel. This is the, let's say, the entire data that we have, right, out of which we divided it into 4 dimensions. Okay, just remember we are left with this one fact table still, right, which we have not created yet. We have created all these 4 dimensions. We have this one table which is nothing but the entire data that we have, which is this one, sheet 1. Okay, now since we have all of these 4 dimensions, now we have this one as a denormalized table. It's time to go ahead with the remaining table, which is the fact table. Okay, so coming down, which is temporary transform data. Okay, so what we would be doing is we will be creating a fact table which is a transaction fact table. Okay, and before this before loading any data into this transaction fact table, first we will be creating a temporary table which will be of a similar structure as of the transaction fact table. Okay, so why are we doing that? Because let's say if I'll go here, let's say we are currently getting the data from all these dimensions from in order to connect to this particular fact and some amount of the transactions, right? So what we are doing is we are having one more table which is acting similar to fact table, which will be a temp table or kind of a staging table. Okay, so that we don't mess up with the main fact table, and also we will be trying to load only those incremental data that will be coming into the final fact table. So let's say for the very first time we will be loading this entire and the data of this fact table from the staging denormalized table which we have with the help of all of these dimension and these measures value. We will be loading the data into the temp table fact, and we will be bringing only those data into the fact table going forward, which will be the incremental data. So for the very first time we will be loading this entire data, and going forward we will be bringing only those data which is the new delta data that is stored into the temp table. Okay, that's the reason we have created the temp table. So if you could see here, let me just first copy this and copy it there, and so that you can have a better understanding. So this temp table, what exactly it has? First of all, it is having a transaction ID, which is a primary key for, or basically the unique key for this particular temp table. Okay. So if you see here, this temp table will be having transaction ID, transaction date, amount, transaction type on all these keys here. So currently in this temp table that we are creating, we are not specifying any primary key as such here. Okay, because this is something staging that we are creating. So we are having this transaction ID, customer key, account key, time key, location key, amount, and this transaction type. And what is the load date, load timestamp for which this table or this value is getting particularly loaded. Okay, so let me just create this. Okay, 1 second. So let's say, let me run this now. Yeah. So okay, so this table is created where we have the transform data as temporary transform data. Now I'll put some let if I'll just put this query there. So now let us try to understand this query. So here we are inserting the data into this table, which is a temp transform table. Now how are we getting this data? So if you'll see, we are taking the data from the staging denormalized table. So the staging denormalized table is that table which is having the entire data. So if I'll just query this staging denormalized table, you could see this is our master data where we have the entire data, right? Now we have created multiple dimensions. Let's say let's start from customer dimension. You could see, and similarly let's say I'll just do for account time and location as well. Count time location. Account, this is time, so this is location. Okay, so if you'll see here, this is the entire data that we have, the master data. Out of this we have created a customer dimension which is having this data: customer ID, customer name, then we have start date and end date for the SCD type 2 and for the flag current flag also for SCD type 2, and we have this customer key which is a surrogate key which is acting as a basically the primary key to uniquely identify this record, these records, right? So that's what it is. Similarly we have account key, account table where we have account key and we have account ID, account type. Similarly we have balance, open date, and all these SED type 2 columns. Similarly we have the time column where if you could see in this main master data we have day, month and year. Then similarly we have created transaction date, just we have kept this transaction date, and we have started, end date and current flag. You could also keep this day, month, year as well. Okay, so but since we are just taking for an example, just created one particular column. Similarly we have the location where we have location ID, location name, and then start and current flag. I hope you would have understood how we divided this one master data into these four dimensions. Now we need to create a fact table, correct? Now this fact table should have all the keys, foreign keys basically, which is customer key, account key, time key, location key, right? Now in order to get all these keys, definitely then we need to join customer ID from this table. Let's say some one table, like let's say we need to join this each one of these table to this main master table in order to get the transaction values, let's say this balance and all which is there in the fact table, right? So we will be joining this table, this denormalized table with customer ID in order to get customer key, correct? Similarly with account ID in order to get account key, then transaction date in order to get time key, and similarly location ID in order to get location key, right? That if you see the query now, so what we are doing, we are taking all the data from the staging denormalized data, and we are joining on the customer dimension on the customer ID, account dimension on account ID, time dimension on transaction date, and location dimension on location ID, right? If we run this, we have got the record. So now let us just see that record. Just run the two tables. Let me just run one. So if you see, this is how our fact data looks like. So let's say we have transaction ID, we have customer key, we have account key, time key, location key, amount, transaction type, road, timestamp, right? Now let's say I want to know what is the name of this customer key, right? So let's say if I'll just run this and this together. See, easily you could relate. This transaction ID 1 is done by the customer key 1, which is nothing but this customer ID whose name is John Smith, and let's say when it started and ended, which is for the SCD type to find, and the amount, and now let's say, okay, now what exactly was the account? So let me just run this account as well. If I just run these three, okay, now you could understand, okay, this transaction 1 was done by customer 1, which is nothing but customer ID this, customer name this, okay, he is having account key 1, that means he is having account ID is this, which is savings account, which is having this much of balance. Okay, so that's how we are basically trying to reduce the redundancies, keeping the fact tables, keeping the dimension tables, and that's how we used to do this modeling. Okay, now we have loaded the data into this temporary table. If you could see, this is the load timestamp, right, which is we have loaded this at this particular time. Now let's go back to the details. Now if I'm coming to the main fact table, okay, so let's create this DDL. Okay, now if you see, we have this transaction ID here, which is the primary key. We have customer key, we have account key, we have time key, we have location key, then we have which is the same which we have earlier. Even in the staging, you could have this transaction ID as a primary, because there also there won't be a case where you'll be having a duplicate transaction ID in case of a business use case. But for many projects, staging usually we try to avoid also primary keys, because it might have a redundant data. Okay, but for banking, it is absolutely fine to have transaction ID as a primary key. Okay, so these are the columns which we are currently defining, and if you could see, these are the constants that we are defining. So we are saying that foreign key, which is the customer key, is referencing to the customer dimension table, and in that table we are having customer key, account dimension, account key, similarly in time dimension and the location dimension. So all of these are the foreign key constants that we are creating. Let me just create it. Okay, now we are good with this transaction fact. Okay, now what is the next step? We have the data that is loaded into the temp transaction table, right? So let's see if I just query, let's start from temp transaction fact. Okay, I've given the incorrect name. Let's just copy the correct name. Temp transform data. Okay, so we have the data here. We do not have the data in the final fact as of now. Okay, now let's say I'll insert this value, insert into, let's say, transaction fact self star from this. Okay, this is saying that it does not match the table definition, because we are having an additional column in the temp transform data, which is the load time. So if you see here, temp transform data is having an additional column, which is the load time stamp, which is not present into the final transaction table. Okay, and that's where it is giving us the error. Okay, so let's say if you want to do it, probably we need to do it like this. Like, let's see, if I'll do this from this, I'll be specifying the column. Okay, let's select this. Okay, so now we have 6 records inserted. So now let me do one thing. Let's start from transaction fact. Let me copy it. So this is the final fact table, and we have this data currently. Okay, now let's say tomorrow there is some new data that has got added to your temp transform data. So let's see if I run that query. So start from temp transform data. In fact, let me run this too. Okay, so here we have additional column, which is load date timestamp, right? So now today, let's say this data get loaded. Tomorrow The load timestamp, let's say tomorrow the data that comes into this staging table first will have the another date timestamp, let's say as 18th November, right? Now when we want to load the data to this here, what we will do is we need to load only those data that is coming from this table, which is the new records, right? So in order to do that, what we will do is we will try to store this load timestamp maximum value into another table. So let's say I'll create a table which is ETL control table. Okay, so let's say if I create a new table which is ETL control, okay, which is having one column as last updated time. Okay, now let's say I just trying to insert some values here. Let's say insert into ETL control last updated time values. I'm just putting some random values. Okay, it is saying that we cannot insert an explicit value into a timestamp column. Use insert with a column list to okay. So let's say if I'll just change this to date time. Okay, first I'll have to drop table. So let's say I'll just drop this table, then I'll create table and I will insert this value. Let's see if it works. Okay, so we are able to insert this date time value here. If I'll just query this, okay, so this is what you could see. We have inserted the data. Okay, now now we need to basically, let's say this value that we have inserted, let's say this is the value of the yesterday's data that is loaded. Okay, now we need to, let's say basically, let's say if you use this query, so basically we have written all those queries so that we don't invest much time into writing it here. Okay, because our main intention is to make you understand. So if you'll see here, we are what we are doing is we are updating this table last ETL control, where we are setting the last update time equals to current timestamp. So this is one of the query that you could use in order to in your project, basically, so that you can update current timestamp every time you run the script. Okay, but let's say for in our case currently we have already loaded the values manually with some random values. Okay, now how do you load it? So let's say if I'll take this one. So what we are saying insert into this transition fact table, which is the main table, select everything from this temporary table, but where the load timestamp should be greater than, select last updated time from ETL control table. And if you remember, ETL control table will always have the last updated time which was run yesterday, right? So if you'll just run this, what it will do is it will bring all those new records. If you'll see here, it is saying violation of primary constant, cannot insert duplicate key in an object, right? Why exactly it happened? Because if you will see here, the last value that we are seeing is 2nd of November, right? And we have already inserted the data on today's date, which is 17th of November. So it will again try to load that data, and that's the reason it is not able to load it. So if I'll truncate that table, to truncate fact table, which is transaction fact. Okay, now if I run this, it is inserting these records, right? Because now there is no duplicates. So if I'll just select star from transaction fact, then this is the data, right? So this is how we basically uh, normalize table from one table into multiple dimensions. Then we have facts, right? And Then finally we can create a staging table, a staging fact table, and from there we can load an incremental data basically to the main fact table, right? And now there are some kind of an analysis which you could see. If I'll just copy or instead I'll just copy one by one so that I can explain it to you as well. So let's say if I want to figure it out, what is the average account balance by account type? Okay, so what we are trying to do here, we are trying to figure it out what is the average account balance based on each of the accounts, like savings account or whatever the account we have, right? So what we are doing is we are selecting account dimension where we are getting the account type, and then we are finding the average of this balance which is coming from the transaction fact when we are joining it based on the account key, right? So that is how we are joining these two tables, and then we are doing a group by on this, and we are figuring out the average of the balance. Okay, so if we'll run this, I'll okay, it's saying that could not because I have selected this, but if I run this here, it will show me what is the account type and what is the average balance for each account, correct? Similarly, if I let's say if I want to know what is the total transactions based on the locations, okay, so let's say if I have this requirement where I want to know what is the total transaction based on each locations, then I can select from the location dimension what is the location name, and we can do a count star for the total transactions based on this transaction fact table, which is a fact table, right? And we can just join on the location key, which is a common column for in across these two tables, and we can just do a group by. So if I'm just running this, we are getting for each locations what is the total transactions that we are doing, correct? Similarly, for this last one, let's see if we are trying to figure it out what is the top customers by transaction amount. So what we are doing is we are joining this customer dimension table with the transaction fact because we want to know what is the top customers, right? So we are joining based on the customer key, and then we are doing a group by, and we are finding what is the total sum of this particular amount for this customer. So if you could see here for each customer what is the total amount that is up there, we are able to figure it out, right? So for any kind of an analysis that you need to do is basically you can figure do it now based on certain write some queries, right? So that's how that's what the intention of a data modeling is, that you should identify the relationship between different dimensions and how exactly it is connected to the fact. Okay, so that's what our the example of the use case. Let us know if you have any issues or if you have any doubts in the use